Okay, I'm just going to do some more examples. I'm just looking at your assignment to go through some of them. Let's do number 48. I'm going to squeeze it right in here. That's okay. So number 48, we have a to the 2/3 times a to the negative 3/5 times a to the 0, which anything to the power of 0 is just 1, so we can pretend like that's gone. We don't even have to worry about that. But if we still had it there, I'm going to show you what you'd still do. So if these are the same, if you remember what we do with the exponents is we add them. So then I'm going to do 2/3 plus negative 3/5 plus 0. A to the 2/3 plus negative 3/5 plus 0. Which if you plus 0, really that's not doing anything. So again, we can just pretend like that wasn't even there. Okay, so 2/3 plus 3/5, we have to make the denominators the same. So I can do a to the, okay, I can make them both 15 by multiplying this one by 5. Sorry, I'm going kind of small, and this one by 3. So that's going to make 10/15, and then plus negative 9/15. So 10 plus negative 9 is 1, so I'm going to have a to the 1/15. And that's it. And let me see if they want you to write it in radical form. Assume that all variables are positive. Leave the answers in rational exponent form. That's it. That's your answer then. You don't have to do anything with it. So the only thing different than what you were doing before is fractions. So just remember that when you're multiplying fractions, you don't have to worry about a common denominator. But when you're adding and subtracting fractions, that's when you have to worry about a common denominator. Okay, let's try another one. Let's do 58. So a to the 3/2, b to the 4/5 all over a to the negative 1/2, b to the 2nd. Okay, so if you remember with fractions, when we're looking at the exponents, you want to see which one has the bigger exponent first, and then you do the bigger one minus the smaller one. But if you wanted to, sometimes it's hard to look at fractions and to say, hey, which one's bigger than, like, which one, because fractions just aren't whole numbers and it's a lot harder to see. So what you can do is just always do the top minus the bottom and then worry about negatives after. So let's do that. So let's just do the top minus the bottom. So I'm just going to do my fractions to the side so that I can write them big. So 3/2 minus negative 1/2. So it's going to be minus negative, so that makes it plus. And these happen to be the same denominator, so I don't have to change them. So 3 plus 1 is 4/2, which 4 divided by 2 is just 2. So I'm going to have a to the 2nd, and since I did the top minus the bottom, a to the 2nd goes on top. Okay, now let's do 4/5 minus 2. Okay, now these need a common denominator, which this one is an invisible 1. So I'm going to times this one by 5 on top and on bottom. So I'm going to have 4/5 minus 10/5. 4 minus 10 is negative 6 all over 5. So then I did the top minus the bottom, so I have to put it on the top. So b is negative 6/5. But since there's a negative, that means, hey, this is in the wrong spot. So right now, it's over an invisible 1, so I just have to move that downstairs. So a to the 2nd over b to, now it's going to be the positive 6/5. That's your answer. Okay, let me see if there's another difficult one that I can help with. Yeah, let's do 68. Actually, yeah, let's do 68, and then maybe 72. Okay, 2 more. Okay, number 68. We have negative 27, a to the 2nd, b to the 3rd, c to the negative 3, all to the 1/3. So now I'm just going to put all of them to the 1/3, which if it's to the 1/3, let's just look at that really fast. If I have negative 27 to the 1/3, that's saying, hey, cube root of negative 27. Now when it's an odd here, that just means if it's a negative and an odd, your answer is just going to be negative, just so you know. And if it's a negative and it weren't an odd, you wouldn't be able to do anything. It would be something called imaginary numbers, which I'm not sure if you'll learn in this class, but that's a little different. Okay, so right here, let's break down 27. So I know that that's 9 times 3. I know that that's 3 times 3. Okay, those are all prime, and I need groups of 3, so 1, 2, 3. 1, 3 gets to come out, so it's negative 3. Okay, so let's go back over here. When I put negative 27 to the 1/3, we got negative 3. Okay, now we just multiply these. A to the 2/3 and B to the 3/3. If you look 3 divided by 3, though, that will simplify, so we can talk about that in a second. And negative 3 times 1/3 is going to be negative 3 over 3. So again, when you have 2 times 1/3, you just multiply across. So 2 times 1 is 2 over 3. And this is over an invisible 1, so you could say 1 times 3. So it's 2/3. And then 3 times 1/3 is just going to be 3 over 3. Okay, so let's simplify these. So 3 divided by 3 is 1. Negative 3 divided by 3 is negative 1. So let's change those. Negative 3, a to the 2/3, b to the 1, but I don't have to write that 1 if I don't want to. And c to the negative 1. A negative we have to write. So since it has a negative exponent, it says, hey, it's in the wrong place of the fraction, so this guy has to move upstairs. And then that'll get rid of that negative. So negative 3, a to the 2/3, b, c. c to the 1, but we don't have to write to the 1. Okay, let's do that last one. It was 72, I believe. Yeah. Sorry, I'm just using, I hope it's useful to you that I'm using your actual homework. Just because these are harder to make up to be like the ones you're doing. At least off the top of my head. Okay. So 25 to the 1/2. Let's go to the side and do that work. So 25 to the 1/2 means 2 goes on bottom, or outside, 25 to the 1. So that's 5 times 5, which, oh, there's 2 5s, so then just 5. Okay, and then 4 times 1/2 is just going to be 4 times 1 is 4. And then over 2. B to the negative 1 times 1/2, so negative 1 times 1 is negative 1 over 2. Okay, and then we're going to multiply this numerator and that numerator by 3. So first, though, 2 to the 3rd. So 2 to the 3rd is 2 times 2 times 2, which is 8. So 1 times 3 over 5, so 3/5. 3 times 3 is 9 over 5. Okay, and then remember we said it's hard to decide on the A's and the B's if which one's bigger. So let's just do the top minus the bottom. Okay, so first let's look at 5 and 8. Is there a number that can go into both 5 and 8? Nope, so then it's just going to stay 5/8. Okay, let's do 4/2 to, let's go over to this side. I'm running out of room. 4/2 minus 3/5. Okay, we have to make a common denominator, so I'm just going to do 2 times 5 is 10, so I'm going to multiply this one by 5, and this one by 2, so you just multiply this one by 5, and then multiply this one by 2 because there's a 2 there, and this one by 5 because there's a 5 there. Okay, 5 times 4 is 20 over 10, 3 times 2 is 6 over 10, so 20 minus 6 is 14. So you're going to have 14 tenths, which can reduce. 2 goes into there 7 times and into there 5 times. Is there a number that can go into 7 and 5? No, those are prime, so then we're done. Okay, so we're going to have a to the, we did the top minus the bottom, so it's going to go on top. To the 7/5. Okay, and then let's do -1/2 minus the bottom, which was 9/5. Okay, so again, same denominator, so we're going to multiply this by 5 and this by 2. So we're going to have -5/10. Sorry, my hand's in the way. I didn't realize that. I was looking at the paper, not the camera. Minus 18/10. So -5 minus 18. Oh my goodness, my mind just went blank. 23, is that right? 1, 2, 3, 4, 5. Yeah. So -23/10, which cannot reduce. So we did the top minus the bottom, so we have to put it on the top. But since it's a negative, now I can just put that on the bottom. So my answer would be 5/8. A is positive, so that stays on top. B is negative, so we take off the negative and put it on bottom. And that's your answer. Okay, I'm going to make a video for the other one.